So I'm just going to continue from problem 1. So this is now problem 2. So I'll look to run my next file, which is find expression, also a Python file. And the user input, which will actually be inputted here, is the expression which you want to filter by or search by. And this, in this case, it'll be food. So yeah, just before I run that, I'm just going to show you the actual code. So as you can see, it's very similar to my last program, which was problem 1. But the only changes are that you're using importing sys, and you will have a user input, which I've specified to be the second input. So this is after the file name. Same clean text method. There's an added filter method which uses user input, which we specified earlier, user input, and filters in the RDD input, which is the first column, this one, which is essentially the word. The second column would be, or the second element would be the numerical value added to it. So this just searches the words, and it chooses those words and returns it with the numerical value, so it returns an RDD. The next method is same as in problem 1, frequency, and create graph, same method. So we go through the same steps, reading the JSON file, selecting the field, mapping it, flat mapping, so changing the words into lowercase, and then splitting. Then we have calling clean text and mapping it, assigning each word value of 1, reducing this, so outputs a RDD with the word and the value. So this could be, it would be very high for very frequently listed words. And the next method is actually where you call the filter method. So you input the reduce text, which is the output of just reducing by key, and use user input. So as you can see, we're calling this method here. And the output will be all the words which match the user input. Then here we go, frequency, calling the frequency method, which once again takes the top 30, and then creating graph. So if I just switch back to running the program, so as you can see here, I'm going to have the user input as food. Just run this and see what we get. Okay, I'll just run it for a little bit again, just so you can see it gets started. Okay, so here we go, different tasks starting. Then we should be able to see the number of tasks, once again 36, so I'll just skip until the end. We can see here that the program has finished running successfully, no errors. So let's just check in our folder. Let's close this and open a new one. Should be saved as find expression graph, I believe. Okay, so we have one here. And so what we can see is obviously once again frequency, word, and most frequent words. Food is by far the most frequent, as I filtered on food, so this has occurred around about 3 million times. The next one is seafood, foods, and then you start to get into the realm of forgetting to put a space in between words, and this maybe happens once or twice, so you can see the rest of them. It's very hard to see how much, but yeah. So I'll just close this. Oops. Close this. And so each program ran for about 16, 17 minutes. I believe problem 1 was slightly faster. Problem 2 had the added functionality of filtering, so that was a bit slower. But overall, I managed to reduce the runtime down from about 55 minutes to an hour down to about 16, 17, 18 minutes. Thank you for watching.